So good afternoon, everyone. I have an Angular talk for you today, but as far as Angular talks go, this is a slightly unusual because I'm actually going to talk about making music with Angular. So this is actually a talk about this kind of curious intersection between two very different things, web development and music. So these are kind of both great passions in my life, and I'm sure that's true for many of us here because there is a kind of special relationship between programmers and music. But I don't think it's quite that common to actually try to combine these two in any way and do both at the same time. And certainly this hasn't been in my goals like ever until very recently. It wasn't until this year that I've started to, first of all, discover that there is an intersection between web development and music, and secondly, to actually try to explore how that whole thing works. And there are a couple of reasons why this is something that I've started to do now. And one of them is a simple, basic technical reason for this, which is that there is an API for this now. There's a web audio API that's shipped across all the major browsers now that they all have that gives us as web developers capabilities to synthesize and process sound right inside the web browser. And so it's deployed across pretty much all the devices and browsers now. And that's great for someone like me who's a web developer, because I spend most of my days just figuring out how to do stuff on the web and trying to learn all the new technologies and kind of building my skill set for web development. So, even though programming environments for music have existed for a very long time, there's never been one that's quite disconnected to what I do every day anyway. So that kind of brings music programming or audio programming to the platform that I'm invested in, that I use every day anyway. So that's kind of the enabler, but this is not really the reason why I've been doing music. The real reason for it is much more personal than that. And that's my growing interest in this idea of generative music systems. So by generative music, I mean this idea of creating music not by means of composing it, nor by even performing it, but by actually creating systems that then make the music automatically. And there is a long history of humans making systems like this. Wind chimes, for example, is a system that has existed or have existed for thousands of years that make music automatically. Very simple music, but music all the same. And then there's a whole kind of lineage of all kinds of experimental music made by systems, especially things like ambient music, and a lot of the minimalist classical music has systemic elements in it. And coming back to the present, many games have generative procedural or algorithmic music engines in them, starting from things like Monkey Island in the 90s, to Spore, to No Man's Sky this year, which has a music system in it that actually generates the music live as you play. So there's a lot of systems like these around, and this kind of music making appeals to me, not just because it often sounds pretty good to me, but also it appeals to me as a software developer, because this kind of music making lends itself to software implementation really well. And that works for me pretty good because I'm a programmer. I am not a musician. I don't play anything. But I do write software. So the leap I'm making here is, what if I could make software that makes music, even though I can't make the music myself? That's kind of the basic idea here. So that's what I've been exploring. And I've been using web audio as my kind of platform of choice for that. And today, there is one particular generative music system that I would like to talk about, which originates with the American West Coast composer, Terry Riley, who is kind of considered to be one of the leading figures of Western classical music in the 20th century, particularly the minimalist school of classical music. And he's a very prolific composer and musician who's done a lot of things over the last 5 decades, but there's this one thing that he did when he was quite young that is especially interesting, not just as a piece of music, but as a generative system as well. So it's called In C, and it was first performed in San Francisco in 1964, so 52 years ago. And it's a piece of classical music, essentially. There is a score that has the music written down on a piece of paper that you can perform from. But it's a very unusual score as far as classical music goes, because it actually only contains one single page of music notation. And on that page, there are these 53 numbered patterns of tiny melodies, very short patterns of music, from 1 to 53. And that's all the music there is to it. But even though there's not much material here at all, the thing is, when you play this piece, you get usually a performance that's more than an hour in duration. So there is something going on here. And that something is this set of instructions that we have when we play the piece. It's kind of English performing directions for how you should interpret this piece when you play it. And you can play this with any instruments and by orchestras of any sizes. You can take a couple of friends and play together, or you can take a full symphony orchestra and play together. One of the biggest ones I've seen was actually here in Kyiv last year. There's the Ukrainian improvisation orchestra who played this last year with 80 performers together. It was kind of interesting. You can find it actually on YouTube if you want to hear it. But there are a couple of rules when you do play this. One of them is that when you play it, every performer should go through all those 53 patterns in the same sequence. So everyone starts on pattern 1 and ends up on pattern 53 and goes through all those patterns in the same order. But crucially, every player has this special freedom to, sorry, I'm going too fast here, has a special freedom to keep repeating each pattern for as long as they want. So as you play this, you can stay on any given pattern for as long as you feel like it before you move on to the next. And that's kind of the magical generative element here, because that means that every player ends up having their own timeline by which they go through this, and two players don't have the same timeline because they choose to stay in different patterns for a longer time, and they go by their own pace. And that kind of gives this piece the generative quality, because that means that even if we have just two players playing the piece together, they're gonna both start on pattern 1, because kind of that's the rule where you need to start. But at some point, one of these players is going to make a decision, which is to jump onto pattern 2, while the other player still stays on 1. And immediately what happens then is that we have two things playing at the same time on top of each other, which wasn't written down on any score. It just happens dynamically at runtime, essentially, as a result of this player making this decision. And then later, the second player might also jump onto pattern 2, and then they're both playing the same pattern again. But because these patterns also have different durations, they're going to be maybe drifted apart from each other a bit, so they're not going to be playing in unison anymore. And here we start to see that from this extremely simple musical material, and from these very few rules, we get this emergent complexity. That's the result of these players making these decisions and these pieces of music layering on top of each other in unexpected ways. And that only gets more and more complex when you add more players to the mix, like the Ukrainian orchestra last year had 80 of these players playing at the same time, or when you get deeper into the score. And so one way to look at this is that it's really not just one composition, this piece. It's really this whole landscape of possible compositions. When you play this piece, you're going to generate a new musical piece that no one has ever heard before in the history of the universe, and no one will ever hear again unless it's recorded. So even though In C has been performed for thousands of times in the last 52 years, there's never been two performances for exactly the same piece of music. And this kind of element of having this much freedom in the piece is really what fascinates me, because as someone who's not musically educated, it just blows my mind that there can be something like that, some piece of music like that, that has so much freedom built into it, but still, if you go and listen to 20 different versions on YouTube or Spotify or somewhere, you will recognize each one as a performance of this composition in C, even though they are completely different. And that just is weird to me that something like that can exist. But the other reason that I find this really interesting is that I can look at this score and I can look at those instructions accompanying the score, and I can recognize this whole thing actually as a system. Because there are algorithms and rules underlying how this piece plays out. And that is something I thought I could maybe explore as a software developer who's not a musician. So that's what I've done. I took this score, this music notation, and I went and translated it into a JSON format that has the same information as the score has, but in a format that's easier for me to work from using code. And then I wrote this music web application on top of that reads the score and essentially brings it to life. And this is a web application that you can run in your browser. And when you do, you can basically play this Terry Riley composition for yourself. And when you do that, you are joined by these 5 bot performers. Each of these 5 bots carries their own instrument that they contribute to the music. And they will play the music for you. But what you get to do as the user is to conduct this orchestra of bots. So you get to choose when each of them joins the music, for example. And then you also choose when these bots move on from one pattern to the next, because they will always keep repeating the same thing until you click them to go to the next thing. And that's how you bootstrap the music. And then you just click your way through the performance, clicking these bots one at a time at your own kind of pace and order that you want to use. And when you do that, you generate your own version of InC that no one has ever heard before. And when you do that, you basically get to these very different places because there are kind of different moods and movements built into that Terry Riley score. And some of them might be consisting of extremely simple musical patterns, but there's this complexity that emerges again when these bots arrive at them at different times and different layers are added to the music, which is unexpected. So that's that little generative music box. And this is an Angular application, an Angular web application that runs in your browser, where I'm using the Web Audio API to play those sounds and some canvas visualization to make those visuals. And so it's an Angular app. It's written in this reactive style, based on the RxJS library and the NGRX family of libraries that uses RxJS to build essentially a Redux-like reactive pattern on top of. And, well, I'm going to describe how it works. At the center of this whole application is this one thing that's really the most important part of all, which holds the state of the application in a single data structure. So there's this one data structure inside there that fully describes everything that's going on in the application at any given time. Who's playing the music? What are they playing right now? What are they going to play next? All these things are going to be in this single data structure. And that is an immutable data structure, which I've annotated here using TypeScript as well, which means that we never change this data structure. Instead, what we do when time goes by is we generate new versions of it using this function called the reducer function, which takes 2 arguments, a state data structure and an action that represents something that happened in the world. And what it does is it produces a new state by doing something with those 2 arguments and returning the new version of the state. And it's a pure function that doesn't mutate its inputs, it just generates and returns a new state. And as we apply this reducer function many times over to successive values of the state, we get this kind of timeline of values that the state takes on over time. And this is something that is actually very naturally modeled as an observable, because observables are a great way to model something like this, some identity that takes on different values over time. So the state is actually an observable in this application, an RxJS observable. And if we take that observable and then package it up together with the reducer function to the same object, we get something called a store. So this is the essence of the NGRX store pattern. It's the combination of your state with the reducer function that operates on that state. And anyone who's used Redux here probably, this probably sounds very familiar to you, because this is essentially Redux. NGRX store implements the Redux pattern, the only difference being that it actually uses an observable to model that state instead of using just a single value for it. But what we can do with this is we can dispatch these actions to it, and it will apply those actions to the state using the reducer function, and then produce new versions of the state, which are then emitted from that observable. So that kind of forms the functional core of the application. This is where the magic happens. But by itself, it doesn't really do anything, though. It's just a function and a data structure lying there waiting for something to happen. We needed to connect this to the outside world to actually make it do things. And in this application, the sort of place where everything springs from is something called a pulse. So the pulse is actually a concept that comes from the Terry Riley's score for in C, because in the score he describes that when you play it, there should always be one performer, one player, playing C notes on a piano with a steady pulse. Throughout the whole performance, it continues the same way. And that kind of provides a rhythmic grid, a tempo for everyone else to play against, so that they are playing to the same rhythm. And the pulse is something you can actually hear in the application as well, in my application, because I've kind of coded it in there. But more importantly, I use this concept of the pulse to actually drive the rest of the music. So I have a little Angular service in there called a pulse service, which models this. And it hosts this little metronome object. And the metronome is an object that produces a steady stream of metronome ticks over time. And those ticks are actually an observable that produces these ticks at a steady tempo. And what I do is I map those ticks using the map operator of RxJS, observable, to pulse actions. So every metronome tick becomes a pulse action. And then I use the NGRX effects library, which has this effect TypeScript decorator, to actually feed those actions into the store. So effectively what I'm doing here is I am taking those ticks and turning every tick to a pulse action, which then goes into the store. So I am essentially dispatching an action, a pulse action, into the store with a steady tempo. And the store will then react accordingly by producing new application states, because the store has an action handler inside it that handles the pulse action. And in that action handler, we essentially make the music. We make the decisions about which notes everyone's going to play right now, and should some of the players, if they're at the end of the pattern, move to the next, continue the current one from the beginning. All these things happen as a reaction to the pulse action. So we're essentially sequencing the music in the store as a reaction to this pulse that comes in. That's how the music gets born, essentially. But it's, at this point, still not something you can hear. It's just a data structure inside the store, and we can't hear data structures. We have to do something more to actually pull it out and make it audible. And that something in this application is another Angular service. This one's called the audio player. And just like the pulse, this also has an NGRX effect inside it. But this effect is a bit different from the pulse in that it doesn't actually dispatch any actions into the store. It just reacts to actions dispatched by someone else. So what this will do is that after every one of these pulse actions that it listens to, it will take the latest state from the store with the latest from operator that comes with RxJS. It takes that latest value from the store, which is an observable, and then it plays whatever sounds needs to be played based on that state. And here I'm using the Web Audio API to essentially play certain notes of certain sample banks at certain times. But it's a very simple service. It doesn't make any decisions about what to play or when to play it. It merely just plays what the state says should be played, and the state is made by the reducer. But this service deals with the implementation details of the Web Audio API to kind of how to make sounds in the browser, how to play samples. But the way I've modeled it is as a side effect of the store. So now we have two of them. One kind of dispatches actions in, and one reacts to actions. And when we wire all of these together, we get this system that actually makes music that you can hear. But this picture is still missing one part, which I have in the application, which is everything you see on the screen, the actual visual user interface of the application. And that part is, since this is an Angular application, unsurprisingly, an Angular component tree. And the way that works is I have this one root component in the application, which you usually have in Angular applications. And into this root component, I inject that store that I've been talking about using Angular's dependency injection. And then I use the ngrx store's select method, select operator, to pull certain parts of the state out of the store. And this is kind of the ngrx equivalent of Redux reselect, or one of those functional selection libraries. With ngrx, we simply use RxJS operators to pull that state out. And what we get out are observables to certain parts of the state. So these are derived from the store. And what I then do is in the root components template, I actually subscribe to those observables using the async pipe that comes with Angular. So this is how we subscribe to the observables. And that means whenever new states are created in the store, the new data from those states is going to flow into the Angular component UI through these subscriptions here. And there's nothing else for us to do. Because these observables are derived from the store observable, and the data just flows in as it's created. And then there's a bunch of other components I have in this application that kind of spring from the root. There's a component tree, essentially. But all the other components are these so-called stateless or pure or dumb components, however you want to call them, that don't know anything about observables or stores, that just get what they need using Angular's data binding system through these component inputs as pure data structures. And this is kind of the equivalent of using props in React to kind of flow the data down the component tree. And they just then render what they need to render based on that state. And then turning that around, when the user initiates an event, we get these events, for example, when they click on one of those buttons, and that event that we then trickle back up the component tree using Angular component outputs. So events reach the root component at some point, where we then go and dispatch an action back into the store. So that's how the root component ends up having a bidirectional relationship with the store. It not only subscribes to it, as we saw earlier, but also dispatches actions back to it. But the rest of the components know nothing about this. They just deal with pure data inputs and event outputs. It's the root component, it's the single thing that talks to the store, which if you're familiar with the smart container component discussion, there's one smart component in this application, which is the root component. And that actually then completes the picture. This is the application architecture. It's these four things that I feel probably form a pretty solid set of architectural primitives for any musical applications. Because you need something to model time, as I had to do with the pulse here, because music is something that happens over time. Then you need something to host your core logic. The store here is where I keep the state, where I create the state, where the music gets sequenced. And then you need something to make it audible, which is the audio service here, and something to control it, which is the UI service here, which also visualizes it at the same time. And I have them here as in a very kind of loosely coupled architecture where they don't even know about the existence of each other. They're just connected together using observables, but they don't really care about each other at all. They just talk through these observable data flows. And well, this architecture makes a few things really easy to do that I would like to mention because I found them very valuable. And probably the most important thing is something that just enables developer productivity for me, which is hot loading. So I have a setup in this project where I can make changes to the code while the application is running, while the music is playing, without having to start from the beginning every time. So I can change the visualization, for example, and then stay there and have it applied there, which is pretty important in an application like this. If you're 20 minutes into the composition, you really don't want to start from the beginning every time when you make a code change. And this is something that, of course, in React is pretty mainstream, but in Angular, there really aren't any hot loading features in the framework itself at the moment. But that doesn't matter to me because I can do it anyway. I can essentially roll my own hot loading because of this architecture. It's really easy to do. And that's thanks to the state being in the centralized place in this architecture. Because as I described earlier, the state fully describes what's going on in the application at any given time. And that means the state is the only part I need to keep when the application reloads. So I can integrate with the Webpack hot module replacement API, which can tell me when the code has changed. It basically has a callback that it calls that says, hey, the code has changed, we have to reload this thing now. All I have to do in that callback is to pull the state out from the store and keep it, hold on to it while the application reloads. So I can let the application get destroyed, I can let a new one get initialized with the new code, but when that happens, immediately I drop in that state that I had, I preserved to the new application. And immediately what happens then is that the same music starts playing that was playing before, the same visuals start rendering that were rendering before, because they are just derived from the state, and the state is the only thing I need to keep. And it's a single variable, essentially. So as far as hot loading implementations go, this is really technically cheating, because I'm not changing code inside a running application. But I don't really care, because it lets me do what hot loading lets me do, which is to just keep where I was and kind of resume working even after code changes in that same application state. And it's all thanks to this centralized state management here. And something like that, to have something like that is actually very important when you're working on an application like this, because you usually have 100 different ideas of what you want to do, at least I have, and most of those ideas are not going to work out. They're going to be bad ideas, but you don't know which ideas are good and which ones are bad until you've tried them out. And you need to be able to test them quickly. If you have an idea, you need to be able to try that out to see if it works, to get that feedback, and then you'll know if you want to go further on that path or go back. And hot loading can provide a feedback loop like that. You can quickly try different ideas and kind of find your way through the thing. So that's why it's an important thing to have as an application developer, that extra feedback loop in there. And I'm saying that we can have that in Angular 2 applications right now, at least if we do it with this architecture, even though there are no official libraries for that. Now, the other developer tool I then have in there is something that, to be honest, I don't use quite as often, nearly as often. It's not as important as hot loading, but it's pretty nice when you do need it. And that's this little component I have at the lower edge of the screen when I'm running this in developer mode, which essentially lets me travel through time. So when I'm working with this, I can at any point grab that slider and drag it back into the past to some state I had in there, say half an hour ago or something like that. And I can also do it the other direction, drag it back into the future. And this ends up being very useful when I, for example, make a visualization change and I want to see how that affects different parts of the composition, because there might be big differences. And I really don't want to click my way through the whole composition for every single code change that I make. That's a very useful thing to have. And again, it completely just falls out of this architectural style. And again, it has to do with how that state works, because the other thing about that state, in addition to being a centralized thing, is that it's an immutable data structure, which means that when we make new versions of the state using the reducer function, we are not destroying the previous states. And that means that we can hold on to them. We can have a developer tool that actually holds the full history of all the historical application states in memory, which then means that we can scroll through that history. We can take any old state that used to be there for a while ago and drop it back in the store as the current state. And it's as if we jumped to that point in time, because again, the music and visuals then start generating from that state. So it's another kind of benefit of modeling your state this way. And again, anyone who's used Redux probably has heard this before, because this comes from Redux. So those are the kind of developer tools I have here, which are enabled by this architectural style. But there's one more thing about this architecture that I would like to mention, because I think it's significant, which is that it also feels like it's very open for extension. And what I mean by that is I can kind of describe that by example of something that happened earlier this fall when I was kind of in the middle of the project. I tweeted about it, of that working version at that point. And this guy, Christian Beaumont, happened to see my tweet. And he works in IoT, in like an Internet of Things company in Amsterdam, where he has a lab with all kinds of things, including a rig of physical controllable lights. And he had this idea, after seeing my tweet, that maybe we could connect these two together somehow. And a couple of weeks later, we decided to do that, and we did that. So we made the Angular application control the lights in his laboratory, and effectively made a light installation based on a Terry Riley composition, which is something that I never expected to do in my life, but it's just one of those weird things that happens because of Twitter. But really the neat thing about that from the perspective of this discussion today is that adding this integration was a matter of simply dropping in one more Angular service to the project, one more NGRX effect that listens to pulse actions on the store. I had to do 0 changes to the reducer, to the state, to any of the UI stuff or the audio or the pulse, just one more file essentially. And this is something that I take as a kind of sign of a good architecture, that you can do new things with it without having to kind of massage all your existing code around it. You can add extensions, add new things, as I did here. And I think that it's kind of, it follows from using this observable architecture where these things exist, but they don't care about each other that much. So I'm able to add, for example, one more output next to the audio and UI, which is the light controller, without the rest of the system even really noticing. So I can do things like that. And I could do other things, which I might still do, which is, for example, take the pulse out and replace it with a MIDI signal, so I could kind of control the tempo of the music from some musical equipment that is connected to the browser using web MIDI. Or I could add other outputs or inputs, replace things, and kind of mix and match these things. And I can do it without the rest of the system being that much affected. And I think this shows kind of how RxJS and observables work pretty well actually as a kind of architectural composition tool where different parts of your system only talk to each other using these asynchronous observable data flows. It's kind of very loosely coupled. And so that's the application. If you found any of this interesting, I have 2 links for you. The first one is a link to a live demo that's on my website that essentially lets you play that musical piece for yourself. It should work on any modern web browser that supports the Web Audio API, which at this point is everything except Internet Explorer. And then the other link is to GitHub. I have a project there that is this application as an open source project. It's a pretty standard Angular Webpack project which you can just clone and install and start and then begin hacking. And that's all I have. Thank you.